Okay, hello everyone. So welcome to the first video, second video for architecture, but this is the first video actually going into how to solve certain questions, right? So we have a simple question here, which is a benchmark program is run on a 45 megahertz processor. The executed program consists of 100,000 instructions, instruction executions, with the following instruction mix. And so we have our instruction type, instruction count, etc. So integer arithmetic 45,000 with 1. Data transfer 32,000 to floating point 15,000 to the control transfer. We have 8,000 with 2 there. Then determine the effective CPI, MIPS rate, and execution time for the program. So first of all, we're going to start with the CPI. And yeah, I just like saying average there so I don't get it confused, but because this is CPI and then this is also CPI, but one is the average, so I just like putting CPI average there. So where we calculate CPI average is by saying the way we calculate is by saying, okay, remember that entire formula that I've shown you where we say something like en I starting at 1, then we're going to have the CPI, etc. That's too long. So if you remember that, yeah, that's actually very, very good. But this is the easier way of doing it, just by saying we get our instruction count. Basically, that's what this formula says. We get our instruction count, which is 1 there. So our cycles per instruction times our instruction count, which is 45,000. 45,000 divided by 100,000. And why might be saying, why am I not just dividing here and there, but and just to avoid confusion, plus then we say 2 times 3 2 1 2 3 divided by 1 2 3 1 2 3 plus 2 by 15000 divided by 100,000 like that, then plus 2 times 8,000 over 100,000. So what's the answer here? Well, I'm just going to quickly punch this into my calculator. So this is 1 times 0.45, right? Which is 0.45, 0.45, then 0.32 times 2, which is 0.65 or 0.64, plus 15000 divided by 100,123, which is 0.5 times 2, which is 0.3, right? Then we're going to have 0.08 times 2, which is 0.16. Then we're just going to add these. We're going to say 0.45 plus 0.64 plus 0.3 plus 0.16, which we're then going to say our average CPI there is 1.55, which in a way makes some sense, which in a way does make sense, because if we look at our CPIs there, we have 1 2 2 2, so obviously our average should lie in between these values, right? Our average should somehow lie in between these values, and of course we do have more of 45 than we do have more of these. So yeah, that's just how to look at them from a point of view. And then yeah, this is our final answer, 1.55. So you can go through, calculate that, but yeah. Then now, what's the next one? Our MIPS rate, right? So what is our MIPS rate? So our MIPS here, so it can be counted in multiple ways, but then I'm going to use the one that relies on frequency. So it's going to be, since we don't have the time taken yet, so it's going to be F over CPI times 10 to the power 6, like so, right? So this is then going to be equal to, what is our frequency? Our frequency is 40. Now our frequency needs to be in hertz, right? So it's going to be 40 times, and looking at this conversion, is times 1,000,000,000, right? Over, what is our CPI? 1.55 times 10 to the power 6. Punching this on our calculator, we'll be able to get the result here. So it's going to be 10 to the power 6, right? So which is 1 million, 1 million. That 1 million will cancel with that one, isn't it? So we're going to say 4 times 1 million, 4 times 1 million there, which will give us 40 million, divided by 1.55 times 10 to the power 6, which just gives me a MIPS rate of 25 0.80645161. So this is our MIPS rig. So that is our result there. Then what is the next part of the question? Our CPI, or our time taken, our execution time. So our execution time, this is equal to execution time is equal to instruction count times CPI times period. Now how do we calculate the period? The period is equal to 1 over our frequency, right? Which is equal to 1 over 40 times 1 million. Because remember, this has to be in hertz. So it's converted in hertz multiplied by 1 million. We're going to have 40 times 1 million, so 1000, 3 more zeros, then 1 divided by that, which on my calculator in scientific notation, to avoid any issues, is going to be 2.5 times 10 to the power negative 8, like so, right? Then now we have our frequency. Then we're just going to say our execution time is equal to our instruction count of 100,000 times our CPI of 1.55 times 2.5 times 10 to the power negative 8, which we're then going to just punch in there. We're going to say 100 and 123 times 1.55 times 2.5 times 10 to the power negative 8, which, if I've punched everything correctly, should give us something like 3.9 times 10 to the power negative 3. Let me just make sure in normal formation, which is just let's just write it normally, which is just 0.003875. I think it's better you leave it in this form right here, in this form and not this form. So this is how you make these calculations for CPI, MIPS, and then execution time. Yeah, so I'm going to make more videos just to go over more concepts. Yeah, bye.